Hello everyone, I'm Daisy and this is my constant velocity experiment. And the purpose of this lab is to apply Newton's first and second law to the real world problem by observing an object moving at a constant velocity, meaning it's moving at the same speed and at the same direction, and then I'll compare it with its computational model built in CloseScript. So here are some fundamental principles. First is Newton's first law. Newton's first law states that an object at rest will stay at rest, and an object in motion will keep moving unless acted upon by a force. And then Newton's second law also knows that the momentum principle is the interaction between the system and its surrounding, and it is related to the change in momentum of the subject. And here's the two main equations that I use in this lab. The first one is velocity update formula. It is used to find the final velocity of the object at a later time, knowing the net force and the change in momentum. And this equation is derived from the Newton's second law here. And the second equation is position update formula. It used to predict the final position of the object given the initial position, and the average velocity in this one is derived from this average velocity equation. In this lab, we assume that there is no air resistance or friction, so the net force will be zero, and according to Newton's second law, the velocity will be constant. And here's some overview of the result of my experiment. And given the same condition into CloseScript, I can say that they both started on the same linear line, meaning that they both move at the same and constant velocity. However, toward the end, the object observed in real life will start to diverge from the computational model. And here's experiment detail. So first, observe motion, and I use tracker to track his motion. And the system here is a soda can, and surrounding is a friction from the table surface and air resistance. And here's a video. The red dotted is the one that I use to track its position. And here are some important information that I found from using tracker. And the initial position of the can is here, and it is at 0.0077 on the x-axis. And the initial velocity of the can is 0.525 in negative, meaning it's going toward the left. And the last time lapse is 1.836. And all of this information I'm gonna be put in CloseScript later on. And here's my snapshot from CloseScript, and I use it to recreate the observed motion and then to compare it with the real world situation of constant velocity. And here I change the ball mass into 0.05 kilogram, which is the mass of my can, and I also change the initial position as well as the initial velocity of the ball. The t started from 0 and delta t is equal to 0.033, which is the time of its frame. And here's the calculation loop, and the final time lapse is gonna be here, which is the end of the while loop. And the net force also set it to 0, so the constant velocity will be make sure. And here's the velocity update formula as well as the position update formula. And then we also update on the time to keep the loop keep going. And here's a video from CloseScript. Okay, this is expected as the can started in the middle and then moving toward the left, and it is the same as the real world observation. But here's a graph of the two motion that we observed. So the red line is the computational model, and it is perfectly linear as the r square of it is equal to 1. But the purple line is our observed motion in real life, and the r square is 0.9934, which is close enough to 1. But as you can see that toward the end, it starts to diverge from each other, meaning that there's some force acted upon my can toward the end that's slowing the velocity. And here's some thoughts after my experiment. And first of all, some source of error. So as I said, there's some uncontrolled forces like the friction and the air resistance that's changing the constant velocity of the can toward the end. And there's also some human error, as I might not point at the center of the can when analyzing its motion on tracker, so it may changing the velocity calculating or the position of the can. I might also choose the wrong velocity to start with because my can is probably still accelerating and not at its constant speed yet, so it might also affect my CloseScript code. What if I flip the axis, like instead of going to the left, I'm gonna go to the right, so the only difference is gonna be the slope of my graph will be upward instead of downward. So in other words, it's just gonna be the changing in direction and not the magnitude. And so is it possible for me to say how many forces are being added together in my case I observed? So no, it is not possible because my case it wasn't perfectly zero net force, and keep in mind that the forces can cancel